So thank you all very much for being here today. My name is Craig Bossy, and I'm a solutions architect here at Amazon Web Services. And today's workshop is going to be all about some of the options available for .NET developers to build their applications using AWS. So today's workshop is going to be split up into two parts. First of all, we're going to take a look at the tools that .NET developers may find useful when developing their applications for AWS. We'll discuss three types of options for running your ASP.NET Core apps in the cloud, and then we'll have a hands-on session to deploy each of those. Then we're going to come back and learn a little bit about the AWS SDK for .NET, which allows developers to take advantage of AWS services in their code. And then we'll see several ways to include DynamoDB in your .NET applications as examples of how to use the AWS SDK for .NET. So first of all, let's talk about the options for .NET developers when working within AWS. So when it comes to tooling, .NET developers have a pretty wide range of tools available to them that are really well suited towards specific purposes. First of all, there are plugins available for the most popular, commonly used IDEs that .NET developers are using. So doing some common AWS tasks and operations really don't require developers to constantly context switch between their development environment and other tools. Then we have SDKs that make integrating with AWS convenient for .NET developers. The AWS SDK for .NET is a set of libraries that enables you to interact with AWS services. Then we have the Cloud Development Kit, which enables customers to model their AWS infrastructure as code, and it supports C# as a first-class language, meaning that developers who are familiar with C# can define and provision their resources they need using a familiar programming model. Then AWS offers a number of command line tools for the developers. This includes the standard AWS command line interface to PowerShell commandlets to the .NET CLI extensions. And we even have serverless application model tools and many others. These tools allow developers to access and provision and manipulate AWS resources from the command line, as well as providing a mechanism to incorporate AWS-related build and deploy tasks in their existing pipelines. So speaking of build and deploy, if you're using Azure DevOps, we provide a toolkit that gives you ways to deploy your code to AWS directly from there. It provides specific tasks for many AWS services, so you have quite a bit of flexibility. We also have our native CI/CD pipeline tools within AWS, such as Code Build and Code Pipeline. These allow you to build, test, and deploy your code all in the same cloud. And then finally, we have tools that can help you migrate and modernize your legacy applications. App to Container helps you automate the containerization of apps to get them out of legacy systems and into containers without any code changes. And the Porting Assistant for .NET makes recommendations and helps with the heavy lifting of moving your framework apps to .NET Core or .NET 5. So as I mentioned previously, AWS publishes toolkits for common IDEs that .NET developers will use. We publish them for Visual Studio, Visual Studio Code, and JetBrains Rider. And here you can see the download links that we'll provide to you. So the AWS Toolkit for Visual Studio is a plugin that makes it easy for you to develop, debug, and deploy all sorts of .NET applications that use Amazon Web Services. And you can integrate with many services that are of interest or use to .NET developers on AWS. Another tool that's very popular is Visual Studio Code, not only for .NET, but really for other languages. Additionally, we've seen a lot of uptake in VS Code for serverless development on AWS. And the AWS Toolkit for Visual Studio Code has an AWS Explorer that's going to be similar to what you'll see in Visual Studio, but really has been created with a serverless first mentality. And this includes tools that facilitate the development, debug, and deploy of your applications. And the Visual Studio Toolkit for AWS also contains CDK Explorer, which allows you to explore the structure of your infrastructure as code applications in real time. And if you're not familiar with Rider, it's an alternate IDE from JetBrains that has gained quite a bit of traction within the .NET community. And the AWS Toolkit for JetBrains Rider is an open source plugin that, similar to VS Code, makes it easier to create, debug, and deploy .NET applications on AWS with a focus on serverless development. So to go a little bit deeper into Visual Studio Toolkit, the AWS Explorer, which allows you to perform familiar actions such as uploading files to an S3 bucket, querying a DynamoDB table, testing Lambda functions, and much more. And then we'll be using the project templates that the toolkit provides and the deploy wizards in the workshop to create and deploy our projects. And we'll also be using the AWS Explorer to view various aspects of our deploy progress and status. And if you're defining your infrastructure as code using CloudFormation templates, the IntelliSense support that it provides can really help speed things up for you. The AWS Toolkit for Visual Studio is available from the Visual Studio Marketplace for Visual Studio 2017 and 2019. And for earlier versions of Visual Studio, we have direct links on the AWS website for the MSI installers. So this is a look at some of the aspects of the Visual Studio Toolkit we're going to be using today in our labs. The AWS Explorer presents your resources in a style that would be familiar to anyone using Visual Studio. The wizards provide step-by-step functionality to enable you to deploy to Elastic Beanstalk, to containers, and Lambda in multiple configurations. And one item of note is that if you're using AWS single sign-on in your organization, the AWS Toolkit for Visual Studio actually can allow you to take advantage of your federated identity, so you don't need to deal with IAM access and secret keys. Some of the tools that are available for use by .NET developers on the command line can be used for things like deployment automation and a finer grain control over your interaction with AWS. For instance, PowerShell users can take advantage of the command line tools on Windows, or even using PowerShell Core on other platforms like Mac and Linux. The PowerShell tools support the same set of services and regions that are supported by the AWS SDK. And AWS has produced a number of .NET CLI extensions that help you focus on building .NET Core and .NET 5 apps and deploying them to AWS using the .NET SDK. These include ECS, or Elastic Container Service, AWS Lambda, and Elastic Beanstalk tools. And then the AWS .NET Deploy tool allows you to simplify the deployment of existing apps to Elastic Beanstalk, ECS, App Runner, or even Blazor WebAssembly. And the Elastic Beanstalk Deploy tool is another standalone tool that can help you deploy your apps to that service. And these aren't the only command line tools available that developers would find of use. We have the serverless application model command line tool for deploying your serverless apps directly. And we also have the CDK, or Cloud Development Kit tool, for building and deploying your CDK projects. So now we're going to see some of the options where you can run your .NET apps on AWS. So when you consider where to actually run your .NET applications on AWS, you have several choices. The three main options that you have for running your code are the following. So first, we have Elastic Cloud Compute, or EC2, and that runs either Windows or Linux. EC2 has pretty much the same capabilities that you'd have on an on-premises server, and depending on the type of application you're running, this may actually be the right choice for you. AWS offers various instance types with different CPU, memory, and performance characteristics based on the needs of your workload. During our workshop, we're going to deploy an app to EC2 by using the Elastic Beanstalk deploy tool. Elastic Beanstalk gives us the same security, scalability, and flexibility that we get from EC2, but it actually manages the deployment of your app and the scaling of your application for you. You can also host your .NET applications on AWS Lambda. AWS Lambda is a serverless function as a service that you can use to execute your code in response to events, such as putting a file in S3, response to an HTTP call from API gateway, or receiving messages from an SQS queue. The AWS managed runtimes that Lambda supports are the long-term support versions of .NET Core, which is currently 3.1, as well as you can bring your own runtime to Lambda, either through self-contained .NET apps or through OCI compatible container images. And finally, AWS provides options to run your apps packaged in OCI compatible format or container formats, such as Docker. You can run your container workloads as a task on Elastic Container Service, or on our Elastic Kubernetes service, or even on our App Runner service. And we're going to see examples of how to run all three in our workshop today. So the compute capacity we just talked about is available at different levels of abstraction in AWS. So we have the virtual machine, the containers, and functions, which is Lambda. With EC2 and containers, you can basically run applications in pretty much any programming language that you want to use today, or that you can use today, which means you can continue to leverage your investments in .NET, whether it's the full .NET framework or newer versions like .NET Core or .NET 5 and beyond. And as you take advantage of cloud native services like our AWS Fargate service, which is our serverless container service, or Lambda, AWS really adds an abstraction layer over the underlying compute infrastructure. So you're really only concerned with packaging and deploying your apps. And at this layer is where the responsibility of managing servers, operating systems, patching, and other non-strategic tasks are shifted over to AWS. And as the abstraction increases, the platforms become more opinionated. For example, as I managed, Lambda only supports the managed .NET runtimes that are in long-term support, whereas you can run .NET Framework or Core of any version in containers or EC2 instances. And as you modernize your stack to use .NET Core, .NET 5 and beyond, you'll be able to leverage more cloud native functionality like Lambda or Fargate. So you can focus then on applications rather than managing infrastructure. So this chart here shows you where you can run your .NET code on AWS. And we have a number of services that enable you. So if you're running .NET Framework and you're dependent on that, then you can select one of our services that runs Windows or supports Windows containers. If you're running the cross-platform .NET Core or .NET 5 and beyond, you have more options. Some services, such as Fargate, App Runner, or AWS Lambda, only support Linux. So you would only be able to run .NET Core and beyond there. However, that really shouldn't be a problem as you modernize into these newer forms of the runtime. Not to mention, if you're running your code on these Linux-based platforms, you can actually see improved performance and save on costs. So now we're going to move on to our first workshop. So in our workshop, we're going to do the following activities. We're going to first get you logged in to your virtual machine with the development environment on it. We're going to deploy an ASP.NET Core web app to Elastic Beanstalk. And then we're going to deploy an ASP.NET Core web app to Amazon ECS in a container using Fargate. And finally, we're going to deploy a serverless web app on AWS Lambda. So let's get to it. So once you've logged in to your environment, we're going to go into our lab guide, and we're going to start using We're going to start using Visual Studio to deploy our .NET apps to AWS. First, we're going to start with is Elastic Beanstalk. Elastic Beanstalk, as you can see from your lab guide, it's a fully managed service it's a managed service that you can deploy your apps of multiple runtimes and languages to EC2, and Elastic Beanstalk is actually going to manage the resources required to run your app. So it will provision EC2 for you. It will provision your load balancers and things like security groups and that type of thing, so that you worry about packaging and deploying your apps, and AWS will worry about the rest. So we're going to use Visual Studio Toolkit to deploy a .NET Core web app to Elastic Beanstalk. So the first thing we're going to do is download the sample ASP.NET Core web app, and there's a link in your lab guide, and you just have to click on the download link, and it'll just save it right to your downloads folder. Once you've done that, you can go over to your downloads folder and just move it somewhere that you can find it. So like, on like the desktop. And what you'll do is you can just extract all, and then just extract it to a folder. What we'll do then, and so you'll get this URL redirector folder. When you go there, go into that folder, and you're going to find the URL redirector.sln file. You want to double click on that, and that's going to open up the application for you. And the application that we're going to run here is a URL redirector. So it's almost like a URL shortener. So you're going to basically be able to give it a long URL, and then you can provide a shortened URL for people to go to. So what we're going to do first is we're going to build this application, and then we're going to run it just to see what it looks like. And as you can see here, this is just a standard ASP.NET Core structured application. So I'm going to run it on Visual Studio. We're going to run this application. So it's going to fire it up in IS Express, and you'll see here we're at our welcome screen. So to use this, what we're going to do is you have to register. There's a username and password here, so just put in your email address, and it's not actually going to send any emails. It's just to create an account. All right, and then once you log in, you just click on the link that says confirm your account, and it's done. Now we have to go actually log into it. So just enter your username and password that you just created. And go to the admin screen. I'll widen this up a little bit. So this allows us to provide our URL shortener. So if you look on your lab notes, it will walk you through how to do this. But we're going to make something that says AWS, and all right, we're just going to go to aws.amazon.com, and we'll add it. So the way to access your URL redirector is we're just going to take the base URL, and we're going to just put /r/AWS. And as you can see, it's just going to immediately redirect us to the website we specified. So that's the app we're going to deploy. So I'm just going to shut this down. Next, what we're going to do is, if you follow the instructions in the lab guide, we're going to use the AWS Toolkit for Visual Studio. And one thing we'll notice over here is we have our AWS Explorer, and we're going to use one of those deployment wizards on the project file to actually deploy our application. So we're going to right click and click Publish to Elastic Beanstalk. And then I'm going to follow along the instructions here if you just want to watch, and you can use the instructions to follow on your own machine. So we're going to right click and go to Publish to AWS Elastic Beanstalk. So AWS Elastic Beanstalk has the concept of environments and applications. So an application is like the site we're deploying. An environment would be like a dev, test, prod type of thing. So what we're going to do is create a new application and environment to deploy this to. And where you see credentials, the application or the environment we've given you has AWS credentials defined already. So that's why we don't have to explicitly add them. But if you were using this on your own machine, you would have to make sure you specify the right credentials. So what we're going to do is choose an application. We'll just leave it as URL redirector. And for environment, it'll suggest some for us. So we'll just take URL director dev. And so then Elastic Beanstalk URLs need to be globally unique. So the easiest way to do this is just to put a hyphen and then some random numbers on afterwards, and then check availability. Okay, that looks good. So now we're going to choose the characteristics of our application. Here under container type, which is the EC2 instance, we're going to use Windows Server 2019 running IIS 10. And we'll just use T3A .medium, use the default there. Or you can choose, it says micro in the lab manual. We're going to leave single instance environment checked. So when you use a single instance environment in Elastic Beanstalk, it just deploys one server for you. When you do a multi-instance environment, you can add a load balancer in front of it, so you can make your web application highly available. For this exercise, we're just going to do a single instance environment. However, there is an exercise at the end of this section on deploying using a application load balancer. So we're going to click Next. And for permissions, we'll just leave these as the defaults. And then we're just going to leave the defaults here, which just tells us how it's going to build it. And once we're done, we actually can just hit deploy. These, just so you know, this right here, this AWS Beanstalk Tools Defaults JSON means that once we deploy this one time, it's going to save these settings to a configuration file, and you can use that configuration file to deploy to Elastic Beanstalk using the command line tool. So that may help make things a little bit simpler for you in the future if you want to automate this. Okay. So what's going to happen is once we've done the deploy, here we go. So, and what we're going to see is it's going to take about 3 or 4 minutes to actually provision this environment. So, and it's going to, if we go over into our AWS console, you can actually, if you go back to, if you go back to EC2 and click instances, what you'll see eventually are some, there we go. Some instances will eventually start to provision with your with the name of your environment. So we'll hold on to this and wait for this to start. So this will, as I said, this will probably take 4 or 5 minutes. While we're waiting for that to deploy, and so we'll come back to that. I'm going to just get us started on our container on our containers exercise. So within Elastic Beanstalk, we're going to publish to Elastic Beanstalk, and then when we're done, we'll go through and test it out. And there's another exercise that you can use after this is completed to use your application load balancer with a multiple instance Elastic Beanstalk. Then we're going to go next into deploying our container on Elastic Container Service. So this is an architecture of Elastic Container Service. This allows you to deploy your Docker containers to AWS, and by using Fargate, which is our serverless version, it's going to AWS will manage all of the underlying infrastructure, and all you have to do is build the container, deploy it to your registry, and then use the container in your registry to start tasks within Fargate. So what we'll do while we're waiting is we're going to set up, we're going to open Visual Studio, another instance of Visual Studio, and we're just actually, for this one, we're just going to create a new application. So, but it's unlike the one we just did, we're going to deploy it to Linux. So we're going to follow our instructions to create a new ASP.NET Core 5 web application. So we're going to create a new project, and we're going to select ASP.NET Core web application. And we'll call this Hello World. And you can leave everything else the same. We'll click Create. And what it's going to do now is we're going to choose ASP.NET Core 5, which we have, and we're going to choose ASP.NET Core Web App. And this is the version with Razor Pages. And we're going to configure for HTTPS and make sure that enable Docker support is checked, because we're going to deploy this with containers, and this will generate a Docker file for us. And on the development environment that we've supplied you, Docker is running. So while that's provisioning, let's go back and see where we're at. All right, so Elastic Beanstalk is still provisioning. And momentarily, our new project is going to come back. All right. So now in our lab instructions for the container, we've actually created this new project, which is just a plain ASP.NET Core demo app. Then there's two steps that come next. And if you're using this on your local machine, you can actually debug this right from the Docker runtime. But because we're running this on EC2, Docker doesn't support nested virtualization. So we actually aren't going to be able to debug our Docker, debug it in Docker. However, we can just go up to our run configuration and select IIS Express, and we can just run it as normal. And let's make sure that this runs. And this is going to look somewhat similar to our URL redirector app, just without the URL redirector part. And here we are. So this is our Hello World app. So we know that that is buildable and running. And I'm going to quickly go back to our URL redirector, and it's still launching. So within our Visual Studio, we're now going to use the Visual Studio Toolkit to publish our container to AWS. And the way that this is going to work is that we're going to specify some information and about the application and where we want it to run. And then the Visual Studio Toolkit will automate building our container, pushing it to Elastic Container Registry, and then it will also start an ECS task and pull that container out of the registry onto the task. And we'll be able to run our web application right within ECS, Elastic Container Service. So what we're going to do is we're going to right-click, Publish Container to AWS. So when we publish our container, we're just going to leave the region and AWS credentials the same. And we're going to make sure we want it to build the release configuration. And then we're going to use the Docker repository Hello World, which is just the same. And then down here on our deployment target, we're going to select Run Task on ECS Cluster. Now there's several ways you can run your containers on ECS. One is tasks, which are individual independent containers. And a service is when you group multiple tasks into one group so that you can actually have multiple instances of the same task run, and then put a load balancer in front of it so that you can have highly available applications using containers. But for this we're just going to run a task on an ECS cluster. And now we don't have any clusters created yet, so we're just going to create an empty cluster. So we'll call this Hello World. Cluster. And it's Fargate, which is our serverless container service. And then we'll leave the launch type and CPU the same. Under security groups, you're going to want to click here and click Create New. And what the security group is going to do is it will actually create a virtual firewall that will let the right ports into ECS to contact our container. In this case, it will be port 80. And under VPC subnets, we just want to make sure that our default VPC subnets are clicked. So it's going to launch our container into one of those subnets. And also, because this is a publicly facing web app, we're just going to click or make sure that assign public IP address is actually clicked. I'm going to go next. So for this task, this is going to be one instance, so we're going to leave that the same. But if we were creating a cluster, we'd choose possibly more than one task. In task group, we'll just call it Hello World Task Group. So for task definitions, these are the templates that are created that it will create your tasks from. So you can actually create more tasks out of this one definition. So we'll just call this Hello World Task. And then for container, we'll just call it Hello World. And so we're going to keep the latest platform. For our task role, this is what your container will use for permissions to access other AWS services. Since we're not doing that, we'll just do create a new role based on Amazon S3. But what you would normally do is if you were producing this, you would have created a role in advance. And for task execution role, we'll just choose ECS Lab Task Execution Role, which is the role that will give ECS the permissions to pull that image from the container registry. And everything else is environment variables and port mapping, and it's the same. So we'll just click Publish. And we'll just make sure that this gets up and running. And then we'll go back and check on our Elastic Beanstalk. Okay, so now I'm going to open up our URL redirector. Okay, so while we're waiting for our container to deploy, we're going to go back and review our Elastic Beanstalk our Elastic Beanstalk deployment. And so if we look at this, first of all, you'll see that it's going to give us our URL that we created, and it'll tell us the status of our environment is healthy. And we can look over here in our AWS Explorer, and you can see we have our application, which is URL redirector, and our different versions. Or our environment, excuse me. So this is the dev environment. Now, if we wanted to, we could deploy a test, prod, or whatever. And then within Elastic Beanstalk, we can use deployment methodologies to deploy to different environments and use them to swap out URLs so that we don't have any downtime when deploying a new version of our application, or to use a canary deployment where we only deploy our new application version to certain percentage of the traffic. If we go look at our server, you can see that this is information about the EC2 instance or instances that make up this Elastic Beanstalk application. If we go to resources, you'll see the resources tab shows all the resources that have been created and are managed by Elastic Beanstalk. So we have this one EC2 instance that we deployed. We have this auto scaling group, which our EC2 instance is deployed to. If we had used a load balancer, we'd see the load balancer and any triggers for starting tasks running on Elastic Beanstalk. Other features in the Visual Studio toolkit of Elastic Beanstalk, we can see our monitoring, which we can see things like network traffic. We can see CPU utilization across our application, latency, other important metrics. And the most important thing we want to see is our application. So if we can just click on that URL. And as you can see right now, here we are in Elastic Beanstalk. We'll just quickly register and make sure that it works. Just going to go through this. Log in. All right, let's just do we'll just do the same thing that we did before. aws.amazon.com will be AWS. So we'll take a copy of our URL, and we'll do the thing where we add an R onto the end, and AWS. And it works. And one thing I'll also note is that it shows you how many times it was used. So one thing I do want to note is if you're using a multi-instance Elastic Beanstalk on an application like this, you need to be careful, because here we just have a local SQLite database that has all the data stored on it. So if you are doing load balanced web servers, you would want to use a database server or something like that to store your data rather than on the individual instances. Okay, so our Elastic Beanstalk is all set. Let's check back in on our container. Okay, so let's go over, and we've deployed it. We're going to review our Fargate task deployment. So what we've created is, first of all, we're going to go over here into the the AWS Explorer, and we're going to go to Amazon Elastic Container Service. And we'll look at repositories, and you'll see here's a container repository that contains that Docker image that we just uploaded to Elastic Container Service. And we'll actually just go over into the Elastic Container Service. We're going to go to the Elastic Container Registry, which is the collection of those container repositories. So you can see here's our registry, hello world. And here's those image tags. There are those images, that's the image, and you can see the tag and other information. And so this is the one that we just uploaded. And if we go into our task definition for Elastic Container Service, you'll see we have our task definition. So we're going to click on Hello World Task, which is the one we just uploaded. And you can see information about the container. And so here you can see for this task definition, it's going to use this container, all that information that we actually uploaded with it. So if we want to go log or go start another task, we have a container definition already prepared with that container, and we can reuse it as many times as we need. And then finally, we're going to actually look to see what we got from doing this. So within our task, we have to refresh this, and you'll see because we selected private or public IP, we're going to get a public IP address and a public DNS name. So I'm just going to take that public DNS name and copy it. And we'll see that our application, here we go, is running or going to our application running on AWS and Fargate. So now we're going to do, and so there's as I mentioned, there's another task deploying your Fargate application as a service with an application load balancer. So I'd encourage you to go take a look at this after the session. Finally, we're going to go over to, we're going to launch a serverless application using AWS Lambda. And this is what the architecture looks like. The way we're going to do this is we're going to deploy an Amazon API gateway, and that will be in front of an AWS Lambda function. And the Lambda function will actually be running the ASP.NET Core runtime. So we will be able to submit a web request to our API gateway, and it will actually forward that on to the ASP.NET Core runtime on Lambda. And then we actually will have eventually we'll have a DynamoDB table that we'll be able to use. So this is in our next session, but this is what the ultimate architecture will look like. So we're going to just go back into Visual Studio and give this a shot. So we can just really go in and do new project. And we're going to see some of those templates. So if you go to C# and choose AWS and clear out web, what we're going to run is an AWS serverless application. And this is one of those templates that the toolkit gave us. And we'll call this serverless lab. And we'll hit create. And what we're going to do, and this is going to give us some blueprints for how we actually want to do this. We know it knows we want to create a serverless app, but what kind? So we're going to want to create an ASP.NET Core web app. So it basically has deployed an ASP.NET Core application, but the structure is going to be a little different than what you may notice. So there's no main.cs. There's two files that are going to be of interest to you. First is going to be local entry point.cs. This is actually the main information, the main procedure. So when we run this locally, it's just going to use this this function, and it's going to just behave like a normal ASP.NET Core web app. Lambda entry point is actually the entry point is a class that AWS provides that is going to be the entry point when it's on the Lambda runtime. So it's going to actually receive information from API gateway, and there's some functionality that will translate it into something ASP.NET Core can understand. So everything else is about the same. So what we're going to do is we're going to open up our Razor page for index.cshtml.cs. And in our application, in our lab notes, we've got some code, which is just all it's going to do is extract some data from FeedBurner for the AWS blog. So and all it does is just get it and save it to a variable. And then we're going to go to the index.cshtml, and we're going to put some code in there that it's just going to display that for us. So first thing we're going to do, we just put in some code to get some data and display it, something that you normally do within a web application. And we'll just give it a quick run and see what we find. So here you can see that it's pulling out those blog entries. So we're in good shape and it's running just fine. However, we want to deploy this out to AWS Lambda as a serverless application. So we're going to use the AWS Toolkit for Visual Studio, and we're going to publish this to AWS Lambda. And there's going to be a procedure that we're going to follow to specify where it actually should go. So first we're going to have a stack name, and we'll just call this serverless lab stack. This is called a stack because this uses, under the hood, this uses the serverless application model. So ultimately, we're going to be deploying a CloudFormation template. And then we need an S3 bucket, and you can just use whatever S3 bucket is there, because this is just for deploying your assets. So normally you'd create one, but we can just put it in whatever's by default in your environment. And that's all we have to do. It's going to deploy this, and the deployment is actually quite fast. So it's going to run a .NET Core publish, and it's going to upload our application bundle to that S3 bucket. And then it's going to take maybe a minute or less to deploy to AWS Lambda. So what it's going to do is it's going to create a API gateway. It's going to create some roles. It's going to create our Lambda function that are all needed to support this serverless web application. So here's the messages from CloudFormation as it deploys. And it's all deployed. So if we look in our resources tab, you can see it says template resources. These are the items that it actually deployed. It deployed our REST API. It deployed a role. It deployed some Lambda permissions and everything that we need to run this. So what we'll do now is, just to make sure, it's going to, because this is a serverless application, it's going to give us a URL. We're going to click on it and see what we get. So now we've run our application right on AWS Lambda. So this is an entirely serverless web application. The last thing I'll make a note is that there's actually two more bonus labs that you can do afterward, which are which show you how to use AWS Lambda with an event based processing. So we're doing a web application. You can just use event processing. So this exercise allows you to take some actions in response to the upload of files to an S3 bucket. Okay, so that is the completion of our first lab. So now we've actually looked at deploying some applications to AWS from Visual Studio, and some .NET Core applications to AWS. Next, we're going to talk about using the AWS SDK for .NET to develop applications that can use AWS services. So the AWS SDK for .NET, it's an open source set of libraries that abstracts away the mechanics of working with AWS services. So for instance, if one of the AWS APIs takes XML or JSON, or if it accepts parameters in the body or in the headers, or it requires you to sign your request a certain way, the SDK takes care of all that for you. And within the .NET SDK, you can use simple C# classes and methods to express your intent, and the SDK will do the rest. The AWS SDK for .NET also includes some extension libraries and tools that actually add .NET specific functionality to your apps. So for instance, we have our AWS extensions for .NET Core, for ASP.NET Core, which allows you to integrate the SDK with the configuration and dependency injection framework of .NET Core. We also have the ASP.NET Core identity provider for Cognito, which allows you to integrate ASP.NET Core identity with our Cognito service for things like authentication. And then the AWS SDK for .NET is distributed via NuGet, and the packages target .NET Standard, so you should have maximum cross-platform compatibility. So the AWS SDK is one of the centerpieces and really a core enabler of the AWS tools for .NET developers. So things like our Visual Studio Toolkit for .NET, some of those command line tools. Majority of our .NET tools actually use the SDK under the hood, and everything that we do in those tools actually uses the SDK. So the same features that are available within those toolkits are all available to you. So there's no hidden or secret APIs that are for internal use only that our .NET tools use. So here in this diagram, you can see the structure of the SDK, and you can see that in particular, we have different levels of APIs. We just have the regular service level API for interfacing with for just normal services. But then we have these higher level utility APIs. So for instance, the S3 transfer utility are classes that facilitate you being able to move files to and from S3. And then the Amazon DynamoDB object persistent utility allows you to interact with DynamoDB using C# classes. And we'll see that in one of our demos. So I want to show you the coding pattern that you're going to use when using the AWS SDK. So first of all, we provide a consistent coding pattern. Here, in order to use the AWS SDK for .NET in your C# code, first you have to use the appropriate usings, so the consistently named service name and model. Then we're going to instantiate a client object for that particular service. So we basically will instantiate it, and then pass any configuration for it to the client itself. So for instance, credentials are something that you need. If you're using this locally, you can configure your SDK to use a particular credentials profile. Or if you're going to deploy this to AWS, you can actually have it use the execution role of either the EC2 instance, the container, or the Lambda function where it's executing. Then we're going to construct a typed request. So here we have a typed request object. So here it's this operation name request, which will have the properties and the data that we will be sending to the service for that call. We'll use the operation name method of our client. So we'll see a concrete example of this, but this is the pattern. So it's going to be client.operation, and then we'll have the operation name request object. So you can send data to it. And then in the background, the SDK will assemble the request. We'll get back a response object. And then we can use the data from that response object in any way that we need to. We can just process our data. Let me just show you a real world example. So this is listing all the items in an S3 bucket. So you can see here, first, we include the using namespaces for our AWS SDK. We create our S3 client object for interacting with S3. We call the operation, which this one is list objects. And then we process the data. One thing I want to point out here is if you look, we see next page marker and next marker. Many of our service calls actually allow you to use pagination. So for instance, with S3, it will return a maximum of 1,000 items. So you can actually, if there's more items than are in your, more items available than can be returned in one call, you can request the next batch of items. And then, so in our workshop, we're going to be using the AWS SDK in several ways to interact with our DynamoDB service. And if you're not familiar with DynamoDB, it's our cloud native NoSQL database for AWS, which is very highly scalable and performant. The three ways that you can access DynamoDB are functionally equivalent, but they each provide you with different models. So first is the low-level API. This low-level API is just going to use that typical model that we just saw a minute ago. It's you have to be pretty explicit with the properties and how you construct your request. Then we have the object persistence model, which is one of those utility APIs. So this higher level API allows you to use POCOs, or plain old C# objects, to represent the data in your table. So from within your .NET code, you can actually manipulate objects which will be mapped to objects in DynamoDB tables. And you can use attributes in your code to map different properties of your classes to properties of the objects within DynamoDB and map your objects to different tables. And finally, we also have the document model. And this model shifts the abstraction away from the client to the table level. So, and it's going to be more reminiscent of a standard NoSQL database where entries into a table are expressed as documents, such as like a JSON document. So which simplifies the coding model while really not giving up any functionality. There's a lab for this that we're not going to do, but you're welcome to do that afterwards. So, and finally, we're going to wrap up our workshop by bringing it all together. We're going to take that serverless web application we made, and we're going to use the ASP.NET extensions for the AWS SDK to consume the DynamoDB API, so we can actually access it in a way that will be familiar to us as ASP.NET developers. So all we're really going to need to do is get the AWS configuration, add new Git packages, and then take advantage of the dependency injection framework provided by ASP.NET Core. So this is just the example of what I was just talking about regarding using that. So we have, first, we can use something like our app settings file to configure the ASP.NET, the AWS SDK for .NET. Then in our startup file, all we have to do is use the extension methods that this library provides to specify which AWS clients we want to inject into or to register with our dependency injection framework. Then you can see here, this is a Razor page, we just use constructor injection to make the particular client available to our code. So now we're going to actually see this in action. What we're going to do is, in our workshop today, we're going to create a DynamoDB table. We're going to access the DynamoDB table in several ways. We're going to, through a console app, we're going to do the low-level API. We're going to do object persistence model. Then at the very end, we're going to take that serverless app we did, and we're going to incorporate the AWS SDK for .NET into that application. So now what we're going to do is we're going to go to our final section of the lab guide. We're going to developing .NET Core applications from DynamoDB. So if you're doing this on your own, it mentions some prerequisites for installing the development environment, but you've already got that taken care of. And what we're going to do first is create an Amazon DynamoDB table that we're going to be using to store our data. So I'm going to just bring up the console here, and we're going to go into the search bar, type DynamoDB. And it's going to be important for, while doing this, to make sure that all the names and everything are typed in specifically as we specify them in the lab guide, just because some of the code samples are going to match the data that we're putting in. So I wanted to make you aware of that. All right, so we're going to go into tables. And first thing we're going to do is create a table. And the table name is going to be called sports items. This is like an inventory for a sporting goods store. So we've got sports items, and then partition key is one part of the primary key of our table. I'm just going to call this item ID, and we're going to make it a string. Then we have our sort key, which is the second part of our primary key in DynamoDB, and this is going to be called timestamp. So any object that we put in to our into our DynamoDB table will be uniquely identified by our item ID and timestamp. And everything else can just stay the same. And we're going to click Create. And it takes maybe 5 seconds to create that. Then what we're going to do is we're going to create a data item within DynamoDB for us to query in some of the code. So we have something to actually get. So we're going to go over to items, and we're going to click sports items. I'm going to do create. So item ID, we're just going to enter in the value 1. And the timestamp is going to be 7-31-2021. we're going to add a couple more attributes. We're going to add one called a string attribute called name, and we'll call it soccer ball. And we're going to add a number for the price, and 3.45. And when we're done, we're going to create our item. So you see here, we've got one item in our DynamoDB table, and we'll use that to query other, to query from our code. So next, what we're going to do is we're going to go in and we're going to create a .NET Core project with DynamoDB support. So we're just going to go back to our virtual machine that we've been using, and we're going to open up Visual Studio. And we're going to create a new project. And for this one, we're going to clear, if you still have this up there, we're just going to clear that. And we're going to choose console app .NET Core. And we'll just call it DynamoDB. And you'll see it's just a pretty bare bones project that just says hello world. What we need to do is actually add support for the ASP.NET, the AWS SDK for .NET into this project. So we're going to go into our solution, and we're going to do manage NuGet packages for solution. And we're going to go to browse, and we're going to type in DynamoDB. And what we should get is AWS SDK.DynamoDB v2. And so we're going to select adding it to our DynamoDB project. And we should be able to go into our dependencies and see under packages it were installed. So now we've added DynamoDB support to this. So we've created the groundwork for this. Next, we're going to see what it looks like to use the DynamoDB low-level API. This is that API where we create a request, we put a request object, we feed it to the operation, and we'll get a response back. So what we've done here in the lab guide, you'll see we've actually just given you the entire contents of the main function, or the program.cs file. So I'm just pasting it in, but I'm just going to briefly walk you through what this does. So what we do is we're just creating a configuration, because I mentioned we have to configure our SDK when we use it, our client when we use it. So we create the Amazon DynamoDB client, and then what we do is we're going to create an item request. One of the items, the parameters of item request is a key, which corresponds to that partition key and sort key that we saw when we created the table. So up here, we're creating an item key, which is just a dictionary of item ID and timestamp. And we're just going to use those values of the item we just made. Here, we're going to get an item, which is, you look at it, it's a get item response. And we're going to await client get item async from that request object. So we're just going to follow that programming model. And the processing of the data that we're going to do is really just to write the data out. And so this is just a statement which will show what we have. So all we have to do is hit the run button. And if everything goes according to plan, you'll see it'll say your item is price 345, item ID 1, name soccer ball, and timestamp 7/31/2021. So we were able to query it, and that's all it took. But using DynamoDB is more than just querying data. So what we're going to do is we're going to add some code in here to actually be able to add data to the DynamoDB database and see what that looks like. So what we're going to do is actually pretty simple. First thing is we're going to take the code from our lab guide, and we're just going to change these parameters and add a couple more. So where it says ID and timestamp, we're just going to replace that. So we're going to actually still query this, but we're going to use these pieces of data to actually insert into the DynamoDB table. So now I'm going to go right here. Make some room for that. Let's take a look at that. We're going to create an item to actually put into our DynamoDB table. So this new item has all of these properties that we've been looking at. And one thing I want to note is that you have the name of an element of your DynamoDB object. And then in C# you use this thing called attribute value. And the attribute value defines what type of data we're putting in. So this says we're going to put in the value ID, and this S field here means it's string. N means it's a number. So you specify what the data type DynamoDB should use is by specifying which property it's assigned to. Then we're going to create a put request. So we're going to put it into this table, and we're going to use that item we just created. And then we're just going to get a put response. And then so we can actually see that it happened, we'll look two ways. One, we're going to query the table with that new value just to make sure it's there. And then we'll go over to the DynamoDB console. So I'm just going to run that. So here we go. We just created our hockey skates. So you'll see price 75, 8/1/2021, item ID 3, hockey skates. And if we go over to the AWS console and hit run, you'll see there's our hockey skates right in the database. So that's the low-level API. It's pretty much exactly as advertised. It follows that programming model we just did, or we just looked at. Next, though, we're going to look at the DynamoDB context API. This is that object model. So this allows us to use POCO objects, or plain old C# objects, that we can define the mapping of the properties of our objects to the attributes of our DynamoDB table. So I'm going to copy that first block of code and replace what's in our database table. Whoops. Let me just go through quickly what's in here. First of all, we define our POCO. I mentioned before that we can use attributes to define that mapping. So for instance, here we have on our class, we have DynamoDB table. This tells you what table this object actually maps to. If we didn't use this attribute, it would try to map it to a table called sports item POCO. So it uses that sort of convention. So here we just called it ID, but we want ID to map to the item ID property within our DynamoDB table. So, and all the other ones are the same. And as you see, we don't have to specify anything other than the normal C# types. And then we just put a toString method so that we can display the value of it. Down here, we do the same thing and create a client and get some data, but we do one more operation where we create this context. So if you've used something like Entity Framework or Dapper, you'll recognize this is sort of an ORM-like behavior where we're just going to create a context which is what manages our objects and how they're related to the underlying data. Then we're going to use a slightly different programming model to retrieve that. we're going to use, from the context, we're going to use the load async function. And that load async function takes a generic parameter of sports item POCO, which is our way of telling it what DynamoDB table to go to and what data to get. And then we're using this method, which is these parameters are our ID and timestamp. And the ID and timestamp compose the primary key of our DynamoDB table. So one of the methods on this context allows you to load based on a primary key value. And there are other methods around querying and scanning and that type of thing. And then we're just going to see what the item is. So now that we've seen this, I'm just going to give that a run. All right, so here we go. We're looking at our item, soccer ball, $731.21, and the price is $345. One thing we'll see, let's just do a quick debug in here. I'll just go here. And if you look at it, the sports item POCO, we're not dealing with things like the S property, the N property, all that. We just have an object which has data in it, and it's going to map that correctly from DynamoDB. Next, we'll do the same thing as we did before, and let's add some data to our database table. So the first thing we're going to do is we're going to go back to our lab guide, and we have some code which tells us how to manipulate this to add data to get to put data. So we're just going to add a bowling ball to our database. And then right down here, let's make some space for that. We're going to create a new object, which is just a POCO. And then we just call save. And it's going to be able to infer everything else. So if we remember, the attribute is going to tell us that ID will be mapped to item ID, and everything else will just be mapped by name. So let's just and that's all we need to do to put data into the database. And as you see, we query it down below. So we have the new item, bowling ball, 101 on June 1st. Let's just quickly go right here. And we'll query the data. And here we go. We can see all of our data is in our database table. Okay. So that's the two ways of that we're going to look at for using DynamoDB. Next, I will say the document model API, there's a bonus exercise for you to do later. And so you can see how that compares to the other two models. What we're going to do next is we're going to close Visual Studio, and we're going to revisit the application that we did before, and it was called Serverless Lab. And that's that application that the serverless website that we created. So if we go into that, that's what we're going to do. If we go back to here, oh, I'm sorry. I just want to show you real quick this diagram right here. This is what we're going to have when we're done here. We're going to add DynamoDB to our application so that we'll be able to make a call using the SDK to get data from DynamoDB. So, and if you recall, we're going to have to do a few things here. First, we're going to have to actually add DynamoDB, the SDK, to our serverless application because we didn't use that before. We're also going to have to add permissions for our Lambda function to be able to talk to DynamoDB, and we're going to do that with our our serverless template file. And this is because if you remember, if what I mentioned before is that we have this serverless application model, and this type of project actually takes advantage of our serverless application model. So the template that it uploads, we're going to specify the permissions right in there. So we'll do that first. So we're going to go into our serverless template file, and this is our SAM template, or serverless application model. And you can see it says serverless right here. And we've defined our function. So this ASP.NET Core function has some policies attached to it. So when we create this, it created a role that it attached to our Lambda function. So what we can do is specify permission, or specify AWS managed policies that we want to be attached to our execution role. So we're going to add this here. It's called Dynamo. Well, I'll just paste it in. Amazon DynamoDB read-only access. So that's going to give us access, or it's going to provide ASP.NET Core functionality, the permissions to access DynamoDB tables in read-only mode. In production, you would probably limit it to just that table, but for the purposes of this exercise, we can just say it can read from any table, but not write. Then we'll save that. And the next thing we need to do is we're going to go back into our solution, and we're going to manage NuGet packages for solution. And we're going to have to add two. First of all, we're going to add Amazon. Oh, sorry. It's AWS SDK dot DynamoDB v2. So we're just going to add that to our serverless function. There we go. Now we're added. The next thing we have to do is add this other one, which is AWS SDK dot extensions .NET Core setup. These are the extension methods within .NET Core that allows us to integrate the AWS SDK with our dependency injection framework and configuration. Okay, so we're added. Now, what we said we had to do next was we have to add the AWS service, register it with the dependency injection framework. So we're going to go into our startup, and we'll just type this in. We're going to do using Amazon.DynamoDB v2, and that's going to scope us to our DynamoDB client, and then using Amazon.extensions.NET Core .setup. Okay, so we're going to go down to our configure services. Oops, I missed it. Right there. Our configure services, and we're going to add the DynamoDB client. So we're going to do services dot. Normally you just do .add. We're going to do .add AWS service and Amazon DynamoDB. So this extension method knows how to will tell the DI resolver how to resolve this interface. Now we need to configure this because we want to make sure it goes to the right region if we don't have a default region defined. So what we would normally do would be to use a configuration method and like our app settings.json file. For this one, we're just going to hard code in US East 1, and our permissions are just going to be the execution role. So we're going to go new AWS options. region equals Amazon.region point.us east 1. And now we have injected, or we will have injected, a fully functional DynamoDB client into our DI framework. So next, we're going to use this somewhere. We're going to go over to our index.cshtml.cs. So you recall before we had that, we displayed those feed burner articles. We're going to just replace the contents of this. And let me just show you quickly what it does. To use our DynamoDB client, all we're going to do is in the constructor of the Razor page, we just inject the Amazon DynamoDB client, and it will be there. Then we're going to create that DynamoDB context. So that was that object model that we used before. And then we're going to, when we do the get method on there, we're just going to do this populate sports items. And that's just going to use the DynamoDB context to basically get all of the values from that table. We could actually do more complex querying, but this is just going to show us everything that's in that table. Then finally, we just have a POCO object here that represents our data in DynamoDB. So we just called it sports items. So that's just going to match it up directly to that table. And here we have, and I've changed it so it's just item ID. Then we just need to be able to display that. So I'm just going to, if you look in the lab guide, we just have a little bit of code that all it does is provide a mechanism to just display the items on the screen. So what we can do first is let's just give it a run. So we're going to go into our local entry point. Let's just make sure that this works. If we get no errors, then we are looking good. There we go. So here's in our DynamoDB table, we've got our soccer ball, bowling ball, and hockey skates. So that looks good. Finally, what we can do is we're just going to update the existing application that's there by going to published AWS Lambda. And what we did before, and because of how we deployed it before, the settings are already there and the stack is already created. We're just going to update the existing stack. And it's going to open up Lambda. And it'll probably just take a moment or two. All right, it's complete. So now we can just click on our URL. And here we are out there in Lambda, and we've got the exact same data. It's pulling it there. So we've just integrated the AWS SDK for .NET into our serverless Lambda function. Okay. So just to wrap up. So first of all, we'll see if there's, after we're done here, we'll see if there's any questions. But before we do, I just want to make you aware of, we have some resources about .NET on AWS. It's a pretty broad topic, and there's really a lot going on. So I'd encourage you to take a look at some of these things and check out what AWS has to offer, and look at some of our YouTube videos and trainings and blog posts that we have, because there's always some great new developments coming out. So thanks a lot for your time today, and looking forward to hearing any questions and hope you had a good time and learned something. Thank you.